The second part of our look at the electrolysis of aqueous solutions is going to involve concentrated sodium chloride solutions and copper sulfate solutions. All right, so again, same intro there. You can see the electroplating of the copper metal on the spoon. We'll explain it again. We'll explain it in a minute here. All right, so determine the products at each electrode when a concentrated solution of sodium chloride, also known as brine, is subject to electrolysis. All right, all of the math is the same. All right, we see bubbles at each electrode, but if you look very carefully, you would notice that the bubbles at the anode, when we, if you do this in the lab, are kind of a yellowy green color to them. This is chlorine gas. So now this is specific to concentrated solutions of sodium chloride. All right, but it does happen. All right, even though the numbers don't necessarily support it, this is one of these things that we've remarked and accept now as fact based on experimental evidence. All right, so you could consider it an exception to the rule, if you will, about how electrolysis will occur, but it is one of these specific to IB examples that we would like you to know moving forward. All right, so yes, the cell potential for this would compute to negative 2.19 volts. All right, it's slightly more negative than the 2.06. That's why this one is actually able to happen. It's not that it's a very large difference between the two. All right, the next one that we're going to look at is what happens when a solution of copper sulfate is subject to electrolysis. Now, copper sulfate is just serving as an example for any type of metal solution, but there is an interesting point about sulfate that we need to look at. So our electrolytic cell here still has water in it, but we'll add the copper 2 ions and the sulfate ions. All right, I'm going to look at the possible reduction here. So this would be copper 2 can accept 2 electrons to make copper solid. All right, this has a potential of 0.34 volts. All right, now possible oxidation. So the negative ion is going to be attracted to the anode, but there is no known further oxidation of the sulfate ion. So if you're in this situation where you have sulfate as the anion in an electrolysis type reaction, happy times for you. You actually can just eliminate this. There's no possible second oxidation here. So the oxidation reaction that will occur is what I have listed on the screen as reaction number 1. So I'm going to now make I only need to make 2 possible cells rather than 4 as we did when we looked at sodium chloride. So this will be, I'll pair up reactions 1 and 3 and then reactions 1 and 4. So 1 and 3 would see the oxidation of water and the reduction of copper, while reactions 1 and 4 would see the oxidation of water and the reduction of water. We can compute the E0 values, or the cell potential, for each of the 2 cells that we've set up here. The first would give me a voltage of negative 0.89. All right, I'll just clean that up. Okay, that was a bad 8. All right, so negative 0.89 volts, while the cell potential for our cell 1 and 4 here would be negative 2.06, same as it was when we looked at sodium chloride. So in this case, the least negative cell potential is the combination of water and copper 2 half reactions. So now what should we see here? Right, at the anode, I'm going to see bubbles. All right, I'm producing gases, oxygen and hydrogen. All right, we should be able to witness and observe bubbles without problem. All right, looking now at the cathode, what should we see? Well, if copper is being reduced, I should gradually see a buildup of a brownish metal. Right, it often looks like hair forming at the cathode. Right, this will continue to build up and up and up over time. This is copper metal that's forming. Okay. Don't forget what would happen to the solution. Okay, copper 2 when dissolved in water is blue, but if all of this copper is depositing on the cathode, where is it coming from? The copper 2 is coming out of solution. So the color of the blue solution will fade over time to clear. All right, so my final question here would be, how would this reaction or this system differ if I were to use copper electrodes rather than inert electrodes like graphite or platinum?